And so the Sustainable Engineering Alliance team has arrived at Hardware Pioneers Max 2026, and it's about 9:30. The show's just opened and it's busy, so we're looking good. We've already got 7 or 8 on-stand interviews already lined up, and we're going to fit some more in undoubtedly, so we should have at least 10 videos from the show today for our audience, showing what is interesting, what's useful, what's new, and pioneering design ideas. So let's hit the show and get on with the job. Right, so here we are, back at Hardware Pioneers Max 2026. I'm on the Winslow Adaptics stand with Teri-Ann Winslow and John Dyson, and we are going to be talking about engineering services for obsolescence. And when I spoke to John recently, we talked about their capability, branded obsolescence surgery. And if we just take a quick look here, service is broken down into 4 pillars: engineering triage, technical feasibility, solutions engineering, and life cycle continuity. So what I'm going to do is ask John to talk us through those pillars, because it's a wonderful way of visualizing that service. Yep. So John, take us through each of those steps and what that means for your customers.
Okay, so first of all, we are kind of known for step 3, which is solution engineering. So that's where historically people think of Winslow, they think of us manufacturing obsolescence mitigations. What we're doing is we're bringing the service back to the very beginning, which is where we do triage, which is where we will look at the problem. So first of all, there were maybe more than one solution for an obsolescence problem. There may be several. Some may carry risk, some may be sort of like no-brainers, others will take some working. So that's the triage process. In which direction do we go then? What are our options? Secondly, then you might need to prove a solution. So is this definitely going to work? That's feasibility. So technical feasibility is about the feasibility study, if you like. The third stage, then, solution engineering is what we're known for, which is manufacturing obsolescence mitigation solutions for people in this industry. And then the last one, let's not forget that the life cycle continuity is what we're talking about here in the first place. We're talking about something that's gone obsolete. Well, if you're looking at 40-year lifespan of a product, there could be many cycles of obsolescence. So life cycle continuity is simply about keeping that monitoring process going. Yep. So that we know what has to be done and what can be done when it inevitably represents itself again in, say, 5 years' time.
Yes. So the first 3 steps, you're going to have to be very careful, aren't you, to make sure that you don't reintroduce a cycle you're going to have to repeat too quickly. You want this to extend out for as long as possible before having to revisit it.
Sure.
Yeah.
We're mindful of that.
Yeah.
And one of the things, we look at people sometimes who are considering last-time buys and things like that, a valid solution in certain situations, but what some of our solutions will offer you is an open-ended, who knows how many they're going to sell, yep, or how many spares they're going to need in 20 years' time. We don't. That's a simple answer. We don't actually know what that's going to be. So if you can have an open-ended solution which offers, almost like a reenactment of that obsolescence solution at some point in the future, then that's the best solution you can possibly find.
It's interesting the way you introduce that within the Sustainable Engineering Alliance, which you guys are members of. We've got a model that we call ACT, which is awareness, confidence, and trust. And it's interesting because these pillars kind of align with this. Your triage is all about awareness, making your customers aware of that challenge, or them making you aware of that challenge to a certain extent. And then you need confidence that the technical feasibility and the engineering solution is going to actually do the job. And just out of interest on that, a lot of confidence is determined by how long a company's been in business, how many solutions it's provided over those years. So, Teri-Ann, what's the origins of the business?
2 years' time will be 50 years.
50 years, okay.
So the business originally started in semiconductors, so we were distribution.
Yep.
We moved into manufacturing really because of obsolescence,
right,
because we had a customer that had a major issue, and we thought, we can solve that. We know how to solve it. And they said, how much do you want? And we said, this much. And we went in there and did it. And the business has evolved over that time. So from being mechanical engineers, 24/7, 150 people at one time, making connectors, pallets of them, to now being a very highly skilled engineering company with electronic design and mechanical design in-house. It means that we get involved in projects that it's about the widgets ultimately, but it's more than that. And what we want to try and encourage companies to do is to come to us at the engineering triage stage, which is, where the red flags are potentially. What are you going to do? Don't have obsolescence right now, then those are your red flags. That's what you're monitoring. So now, let's look at that. Is there an opportunity here to do some engineering work, some NRE, to establish a solution now? It could be that you even go to pre-production stage, and the potential savings that we actually have seen doing this already is huge.
Give me a clue as to some of the red flags that a manufacturer should look for as an indication it's time to talk to you. What sort of things would they see that would alert them to that, do you think?
So if they have an obsolescence management plan, then they will understand where their risks are. They will have already found out that X amount of components, mechanical parts, they're critical to the build. And if that becomes obsolete, we're going to have a problem. In some companies, they may not have an obsolescence management team. They may not even really understand at all. They may not have got onto that step. So, we all know about allocation, and we all know what post-pandemic was like. And that affected many industries that probably didn't even ever need to think about obsolescence, not really. But I think, so the red flags are often very late. So we become reactive. We want companies to talk to us proactively. And they do. And I think there's more and more thinking around now. But also, when you're designing something new, so, we're talking about hardware pioneers here. When you're designing something brand new, are you thinking about sustainability and the future of our planet and the next generation after that and after that,
Yeah, that's an interesting point. I mean, being at Hardware here, this is an exhibition very much centered around new product innovation, startups, technology, and it's easy to become overwhelmed by all of the new stuff that you've got to do. And I guess what I'm trying to encourage people to do these days is just somewhere on your design checklist, just put longevity. Just one little box. Have we thought about that? And as you say, identify components that do represent high risk, I guess. Use some of the bill of materials services to see maybe when those are going to go end of life, if the manufacturer makes that information available. I know some do, some don't. And then come in at triage. And what does triage involve? How long does it take? Do they just phone you up and say, triage this part, please? I mean, John.
I think every situation is different. There is no one magic formula for obsolescence, and I think it's crucial that people speak to us early. And this is what Teri-Ann was saying earlier on. It's the most important thing is speak to us right at the very beginning, because maybe there are two sources to your product. Maybe there are two products that possibly could even be designed in at the beginning. Why can't we design multiple alternatives into a design? There are lots of things that, if considered at the right stage, can save so much money and so much time and requalification costs and so on further down the line.
So yeah, just on sort of multiple sourcing or dual sourcing, there's no reason why you couldn't have an input to a design literally at concept stage, in theory.
Absolutely.
Maybe even PCB spacing and space around a device in case it needs to be removed and replaced. Yeah, it could be that early.
Absolutely.
Yeah.
And I think, there's always going to be designs where space is premium, and we get that. So it's not a one size fits all. But it's if you're having the consideration, if you're talking to a company like ours where we're involved in the legacy before it becomes a legacy, then you've got a better chance of being able to solve the problem when it arises.
Yeah, this all makes so much sense. So I'm just going to reiterate this now. So your triage is really an awareness process where the customer's making you aware of that challenge and some of those. And that, yes. And then the technical feasibility and solutions engineering, that's all about confidence in the solution. And you've got 50 years to back that up. Now, it's a trick question, you might not be able to answer. How many projects do you do a year? I'm trying to work out how many you've done over 50 years. Is it 10 a year?
If I tell you that, I might have to kill you.
Yeah, well, yeah, hopefully we won't go quite that far, but hundreds, thousands of examples of work you've done over that
I would say thousands.
Thousands.
Yeah. I mean, and that could be anything from a simple device change with maybe even a standard off-the-shelf product for us to an extremely complex, re-engineered high-voltage connector.
Right. Okay.
We are driven by the customer and what he needs for the machine.
Yeah. So super confident in that, and then ultimately trust in the brand and team. You've got the engineers to talk to, and I guess if you need specialist skills, you've got partnerships that you can tap into as well.
We are an umbrella, if you like, around the obsolescence reign, and we will take our customer through all these stages, or indeed one or two of the stages. If they have already started the process, we'll actually come in at any point. Best thing to do is to come in at the beginning, but we will look after the whole project.
But you can dovetail in if a project's already underway. Brilliant. And the show itself, I think, this is your first time at Hardware, yeah? And how's it going?
I mean, it seems really dynamic.
Yeah.
It seems, that people want to talk and they're interested in having a kind of a conversation around all sorts of things, whether it's a new product or something that they're working on that's legacy. And I think that's what we need in this industry. We all need to be open and have really good discussions. It doesn't matter if it's not on brand or it's not on trend. Who cares? Let's just all talk, because there's so much knowledge out there.
Well, I think you guys being here is fascinating, because my perspective of engineering has changed quite dramatically over recent years. I no longer see it as a linear process where you design something, make it, use it, dispose of it. I now only see the future of engineering as a circular model. And to a certain degree, the services you provide are kind of at the tail end of one of those loops. But these guys here with their new products, you simply dovetail into the beginning of that. And so round and round the model goes. And so both those engineering teams looking at innovation need to be talking to you right now so that their product can be modeled in a circular fashion and evolve and last forever. Is that a reasonable thought process?
Absolutely, yes. So you've closed it off for us. That's great.
Close the loop.
Perfect synopsis.
Fantastic. So
Marseille is academia. Is trying to educate the young engineers that are coming in and they're thinking about designing new products. Think about the sustainability of that, really.
What we're trying to do at the Alliance, through the magazine, through the website, through these videos, is try and get that circular thinking process as one tick on that checklist. So if you've got a design criteria, just add one extra row that says sustainability, circularity, and then everything flows from there. So, let's conclude on that. So guys, have a good show.
Thank you.
And we'll see you again soon. Right, here we are at Hardware Pioneers Max 2026, and we're on the NCAB stand, and I am with Scott Williams, and we're going to be talking about a couple of things today, just general market conditions, because markets go through cycles, and so it's going to be interesting to find out where we are in that. But also, Scott's going to summarise some new information that NCAB has just recently launched about environmental guidelines in terms of printed circuit board design and manufacturing. So, first of all, Scott, just tell us about the market conditions at the moment, what's happening, what readers should need to know.
I think at the moment, I don't think the PCB market has ever been as volatile as it is. We are really in unprecedented times. What we're seeing is really extended lead times, both from manufacturing times because of the capacity constraints, as well as the main issue we got is actually the raw material availability. A lot of factories, certainly within China, are now really riding off the AI bubble. And we are just seeing the spillover of that now really come into effect.
Yeah.
So we know that certain factories have really got large contracts in place with Google, Amazon, NVIDIA, all the big players in AI. So we are now seeing that material is being hoovered up.
Yeah.
So a lot of the laminate manufacturers are focusing or converting the material to be ready for AI application and the low DK, low DF applications. So it is making raw material harder to come by. We are seeing, if the factory don't have it, depending on the brand, depending on what the quantity, could be anywhere from 10 days or in some instances we're seeing up to 90 days of material. So yeah, I think the biggest part of my job now is actually helping customers understand the market and really managing expectations. We're obviously seeing pricing continue across the board. I think when we spoke at Southern, we really spoke about gold and the impact of gold and how we were looking at variations of different surface finishes and cost benefits against performance benefits. We're almost kind of past that now, where cost is no longer the primary driver. It's all about availability. If a factory has material, this is the price, this is the lead time. If you want product to market, you are going to jump on that opportunity. So yeah, we very much, what's it been, 4 months? 3-4 months and 7, it really has developed really quickly. So yeah, it's the one benefit that NCAB continue to have. We are still in regular negotiations with our factories. We've still got a very strong presence with our factory management team. We're continuously getting updates that we're sharing with our customers. We still have our reserve capacity. We still have priority material when the factories get hold of it. So that we're finding that leverage of scale is really important, and it's probably more important now than it ever has been.
Right.
So yeah, partnering with NCAB, our customers are feeling the benefit. And so hopefully we will help navigate these choppy waters for our customers. Yeah, we will do what we can.
And if there was one thing you would advise your customers to be doing right now to sort of build in as much resilience as they can, what do you think that might be?
I think at the moment, if you're looking at designs, you don't want to be too laminate brand specific. I think if you can just go with your IPC / codes and be like, we need material to match this. Because what we're seeing is there are certain materials that are being used in more for AI supporting applications that are becoming longer to get hold of. So actually, if you can specify just a certain TG rating and you can use any equivalents, factories have got more flexibility to offer some materials.
Right.
NCAB have always gone down a international branded laminate route, so Isola, iTech, Shengi. What we've actually done over the past 6 months because of the material situation is we've actually now approved a handful of local Chinese laminate use. We've had them in, we've tested them, we have proven that they are a equivalent acceptable material. There's some that we've disqualified because actually when we put them through the testing, they didn't meet our requirements, so we weren't confident that they would be applicable for our customers. But by offering this, we are helping in shorten the lead time.
Yeah.
So even if the factories don't have the local laminates on the shelf, there is a chance that actually that is going to be easier to get hold of than the international brands. We might see a 10-day lead time for that material than a 35 to 50 day for the equivalent of an international brand.
Yeah, that's interesting with the equivalent. So you've pre-qualified them through your own in-house test procedures, so your customers can have confidence in going with an equivalent if necessary, because they've been through that test process.
Yeah, absolutely. And it's one of the benefits of coming to an organisation of the size of NCAB. With our team over in China, we have had them in, we've tested them, we've taken them to our own NCAB lab in China. It's all been approved, and there's, like I said, there's only 3, maybe 4 brands of all the laminates that are out there that we've deemed acceptable for the quality and the reliability that our customers expect of us.
Yeah, interesting. So example there of scale and in-house test capability, allowing equivalents to come into the purchasing process. So Scott, the second bit of news, which I think you can just summarise at the moment because it's all quite new, is your new, what would you describe them as, environmental guidelines?
Design for environment.
Okay.
So we've always had design guidelines, and I think as we've evolved over the past 2 or 3 years, we've certainly looked for a more sustainable option, turning the market in a greener method. So I think this is just a natural evolution of that.
Yeah.
So yeah, the guidelines are very new. They've been out maybe a week or so. But yeah, it really talks about looking at your options now in terms of, are you making a product that is the most sustainable option? Is it the greenest option, and actually the payoff from going for that option to what your product is going to be. So it talks about the new materials on the market. It talks about choosing a halogen-free solder mask in comparison to a different type. It talks everything from panelization to actually, if you're looking at your standard construction, the default has always been 1.6 mil. Always been that. But why? So it really challenges actually, does it need to be 1.6, or could you get away with using 1.2? Could it be a millimetre? And actually changing the construction so that you have different prefabs and cores to make up that, but you're not losing the mechanical stability of the product by changing from a 1.6 to a 1 millimetre construction. But you're saving 20 to 30% of the material content. You're then reducing the weight of the product when you're shipping it around. So it really covers things like that. It also goes into the copper weight. Do you need to have 1 ounce, or can you live with half ounce? Can you live with 12 microns of copper? So it is really now pushing the boundaries of when you are starting to design your product. If you take it from a green hatted point of view, these are the things to look out at. These are your key triggers. These are the things that on the sustainability chart that we have on each section, this is the environmental impact it's going to have. So yeah, I think it's a great tool for anyone looking to design a green PCB. So yeah, and we're here to support. When this is available, it's available to download from the website. You have questions, the NCAB team are here. We've got FAEs, we've got technical team, we've got your sales managers. Reach out to us. We're happy to discuss and see how we can aid your latest designs and make sure that it's meeting your requirements.
And so I'd imagine, having read through that, design engineers could turn that almost into a sort of checklist that they could deploy quite easily at the start of a design. I see. I'm a design engineer myself. I suffer from these problems myself, which is a lot of design is habitual. You always do what you always did, and it takes information to kind of break that chain and get you to rethink. So that sounds like this is an opportunity to do that, to just stop and rethink.
Yeah, absolutely. I think that is the ultimate purpose of why these sort of guidelines are now there. I think using them in unison with our design guidelines that are available for multi-layer, for flex rigid, for HDI, they're available off the website. I think using it in unison with that, where you're looking at actually the boards need to meet this criteria, but actually if I change this, what impact is it going to have? So yeah, I think using the two combined is going to be a great tool, and I think, like I said, helping to break that habitual habit that customers go, right, boards will be 1.6 and they will be panelised in a certain way, and we will have 10 mil waste all the way around. Well, actually, take a step back. Does it need to be that? Could we get away with scoring them instead of having grout and waste? You reduce the size, you reduce the square meterage. reducing the weight as it's travelling, so you're making an environmental impact so you can benefit from that point. You're also potentially saving cost because you're not making as much.
No.
So yeah, it's all geared to make sure that it's the most reliable, sustainable and cost-effective version of itself, meeting the requirements of customers.
So yes, as part of any sustainability design work, one of the mantras would be just reduction, just to try and reduce things. And so I'm assuming if you're reducing the reinforcement, reducing the polymer, reducing surface coatings, etc., there is the opportunity to save some money along the lines as well.
Yeah. I think there's always been this stigma that sustainability is going to increase pricing. I think we've worked hard over the past few years to really try and change that and flip it on its head. If it's implemented successfully, it should be a cost saver.
Yeah.
Because actually, like I said, if you're looking at it just from a panelisation point of view, if you reduce the panel size, you reduce the square meterage, you should be saving money on square meterage, but actually you're transporting less cost, so your freight costs are going to be less. You're going to need less surface finish. You're going to need it. All has a knock-on effect. So yeah, if done correctly, it should be seen as a benefit and a cost saving. But it needs to be done with the right intentions and implemented at the start of your process. Engage with us early, have those early discussions. The technical team are great, they're well versed in it, so yeah, we will be able to aid our customers to guide them along this journey.
Right, well, thank you very much, Scott. Two very important learning points there in terms of supply chain resilience and environmentally sound design. So thank you very much. Have a good show.
Thank you very much.
And we'll catch up with you soon. Right, here we are at Hardware Pioneers Max 2026, and I'm with Robert Otręba from GRINN, and we are on the Solsta stand that is representing GRINN here today, and we could not walk past this stand without stopping to check this application out. And I've tried it a little bit before, so I'm going to put my hand there, and I'm gonna absolutely crazy. So with a background in automation, I can't even imagine being able to control mechatronic systems like this from the days when I was doing this, and now clearly here we are on exhibition stand. So, Robert, please explain, how is this technology working? What makes it different? Where's it going to be applied?
Sure. So this application is showcasing how to use our system on modules with Edge AI capabilities. So we are a manufacturer of the system on module like those, the world's smallest system on modules based on Synaptics, MediaTek, and Renesas processors. And what is unique here, that these are not only application processors, but they have also integrated neural processing units to run AI algorithms on the edge without any cloud connection. So this is just a simple application how it could be used for gesture recognition. For example, for controlling different type of things. But of course, instead of gesture recognition, it could be whole posture recognition. It could be, I don't know, nameplate recognition. It could be people detection. So there is a bunch of applications that can run on the edge without any cloud connection, and it can be really utilize the AI technology on this. So, yeah.
So one of the interesting things with this type of technology at the moment is around sort of cybersecurity. If you've got automated factories, connected factories, smart factories, there are going to be areas where you want to isolate that from the cloud and operate locally. You may want to keep data secure, etc. So under those environments, you'd be able to operate in this type of system on module?
Yes, exactly. So any type of robotic system, drone systems, I don't know, devices that can't be connected or we can't rely on the internet connection, implementing AI on the edge is crucial. In case of robotics, as you told, the time, it's a key thing. Not reacting in the proper time manner and relying on the cloud computation, it's not possible.
Yeah.
Sending some data to the cloud, if they are really sensitive from the company point of view, it's also not an option for many types of applications. Right now, technology, it's there. So those type of really complex products can be built faster using the system on modules, and Solsta is helping us to educate the customers, showcase them what is possible, and that's why we build also this demo.
Okay. And to implement this, obviously Solsta is here representing your brand today.
Yes.
What would our readers need to do to sort of buy into this technology if they need design support and that type of thing? How does that relationship work?
Yeah, so of course on our webpage we have a full product portfolio, and the customers can find the data sheets, SDKs, all the necessary knowledge. But Solsta is helping us to really to work together with the customer, to be close with them, and also to solve their issues, to source the components and so on. So we are working in practice as a one team. They are representing us in UK and Ireland. We are at the back side, we are providing all the deep technical support, but we are working together to make the customer happy.
Okay. So yeah, so as you say, software development kits can be downloaded from your website to get started.
Yes.
And I'm just thinking, my mind's running away with me now, looking at gesture control like this. I can see a future where maybe there's a humanoid robot controlling a machine through gestures of their own hands. Who knows?
Yes, it's already happening. It doesn't need to be only gesture. There is also a possibility to build LLM models, local LLM models into this, and we have such requests from the market. So there are already appliances that are built that instead of controlling with knobs or with typical HMI displays, there will be voice interface to this, because people used to use this because of ChatGPT, Gemini, and all those tools that they are using on their PCs. Right now, this technology needs to be turned into edge. So that's why we are building these products, and that's why with Solsta we have such approach to such customers.
Excellent. I look forward to the factories of the future and the applications of the future where this is deployed. Thank you very much. Right, here we are in the chill out zone at Hardware Pioneers Max 2026. And guess who I have bumped into? This is Jack Herring, who is from Jiva Materials. So Jack, why are you at the show? What are you hoping to achieve during your trip here?
So the main reason is that there are very few shows in the UK in terms of the space that we're working in, so we're just trying to basically show people what we do, try and find some new commercial opportunities as we're looking to scale. There's lots of people within the PCB fabrication space here who we work very closely with, and there seems to be a very good presence of people from all over Europe who would be very good use cases for our technology in the IoT space, in microcontroller spaces. So for example, there's Arduino here, there's Raspberry Pi here. Yeah, just an opportunity to really tell people about what we're doing here in the UK.
So a bit of both then. So manufacturing partners, companies you deal with to produce PCB, and then application case studies as well. Yeah. And out of your rucksack, you magicked some samples here.
Yes.
It would be really useful, because this is such a novel technology, just to step through some of this, maybe starting with some of the raw materials, moving through the PCBs, and then to a kind of to a finished product effectively. So what do we see here?
Yeah, sure. So if we start right at the beginning, this is an example of the natural fiber that we use within our products. So this is the lyocell, which is cellulose, which is derived from eucalyptus. So this is effectively replacing the glass fiber, which is currently used in FR4 and a number of other incumbents in the industry. We've seen a very, very drastic price rise with these incumbent materials recently because of the glass fiber, which is driven by the boom of the AI industry. So this has actually allowed us to become cheaper than the likes of FR4 for the first time on our journey. So, and that savings only going to increase as we scale production. So, we then use that to produce our composite material. So this is a Soliboard material, which is the natural fiber reinforcement combined with our biodegradable non-toxic polymer, which is also water soluble at end of life. And then we supply that as copper pad laminates to PCB fabricators, the likes of Garner Osborne, who are here at the show today. And we use that to then basically produce a PCB or a panel of PCBs using industry standard PCB fabrication processes. So our material is a drop-in replacement for the likes of FR4. It goes through a standard factory drilling, plating, everything as standard. And then we can use that to produce the likes of this, where we have a PCBA, which is assembled with all manner of components down to 0201 size. And this is an example of a microcontroller board which has energy harvesting capabilities, supercapacitors, PV cells. And we assemble this using low temperature solder, which is energy saving further downstream, and also an additional carbon saving on top of the 68% that we already offer.
Yeah, wow. Absolutely fascinating. And in fact, as we walked past the Garner Osborne stand, I saw they had a big television set there playing the video where we took a look at some of your boards being produced there, which is great to see. From my perspective, I've been on this kind of journey with you now for a couple of years, and the thing that really gets me is just the quality of the finish of that board.
Yep.
It's magical in terms of its biodegradable capability, but just the engineering perfection that you've got in terms of the structural finish of that board, and most importantly the surface finish. And the way the market's moving at the moment, a lot of people are always concerned in terms of sustainability. They're worried there's going to be a cost penalty, but in fact what you're effectively saying now is there's cost saving.
Yes.
Yeah. So this technology has come of age, and on that particular point, I know we can't talk to you for too long because you're about to head to the airport and jump on a plane to head out to another event to push this on. Tell us a little bit about that event and what you're doing there.
Yeah, so I'm heading to Amsterdam in a couple of hours for an event called Hello Tomorrow. It's an investment-focused event. We're trying to identify some strategic investors as we look to scale this technology. And basically, we're trying to build upon this Series A investment round that we're launching immediately, effectively. And this is all about sourcing funds to build this continuous manufacturing process within the UK. This will allow us to produce our material in hundreds of thousands of square meters as basically building upon these commercial opportunities that we have from a number of different customers in different market segments. It's a big event for us, and very, very excited.
Yeah. Well, good luck for that. And from the Sustainable Engineering Alliance's perspective, the importance of conversations like this, from my perspective, are that a lot of design decisions can be habitual. If a manufacturer has used a particular material for a long time, there's always the thought process, we'll just repeat that process again on a bill of materials. But sometimes you have to stop and rethink. Sometimes you have to draw a line in the sand, get a checklist out, and as environmental legislation and regulation starts to move in across Europe and the rest of the world, now is a time to stop and rethink. And these are the types of materials you need on that checklist. So I encourage our readers to do just that. Make sustainability the first stop on your design checklist. Ask a few questions, test the materials, prototype, and then make an informed, data-driven decision, which you may just find saves you some money. So thank you for stopping with us and introducing us and our viewers to this. And we best let you go and grab your flight.
Yeah. Thanks, John. It's great talking to you, and it's hopefully going to be a big week for us.
Right, here we are at Hardware Pioneers Max 2026, and at the moment I am on the BEC Group stand, and I am with Paul Holland, Technical Director, and we're going to be talking enclosures. So from a sustainability perspective, the question is, how does this organisation work with its customers to optimise the mouldings to minimize the amount of material that's necessarily used, to make sure that the cycle times and the energy consumed during that process are also minimized, and then potentially to include recycled material where appropriate. So what I'm going to do is ask Paul to talk us through the types of conversations he has with clients, how to optimize and tweak those designs to make sure that they're the best they can be. So best practice design for manufacture for molded enclosures. So, over to you. Talk me through that process from a customer first contact.
Well, if we take a general case sort of example, a customer will come to us with a step file which we can interrogate. We can actually use MoldFlow, which is an FEA program, which we can predict extended cycle times, excess materials, distortion and warping, and it's in everyone's interest to cut down, not to the bone, but cut down excess weight off of the mouldings so that we get a better product out. We also use less raw materials as well as cutting costs, which is ultimately the customer-driven part, is very important to them. And the customer's design team would talk to our tool makers, and between them they can actually sort out as to the best way to get to the optimum design of their parts.
So it's literally a one-to-one conversational process,
yes,
where they're bringing, say, a step file, CAD file, coming to you, run that through MoldFlow, take a look at the options, conversation between yourselves and the customer as to how to do that. Give me, use some sort of maybe case study examples of the types of improvements that you can achieve. You were mentioning sort of wall thicknesses and things. I guess maybe an OEM might habitually use a particular wall thickness, whereas in a new designer product they may be able to step back and rethink that. Talk me through some of the actual practical applications of that.
A lot of parts now are designed for 3D printing, which is a fantastic tool, but 3D printers can print things that injection molders can't make. So we have to then correct it. 3D printing, you get a thick section, you just use more of your filament up. For us, it's more a matter of identifying the problems that haven't been identified, and we would then design out the cost, design out the problems, and that's the first stage we do, is generally part of our quoting stage. When the parts come in, we would then feed back to the customer, as well as giving a price, observations we've made of problems that we can see with their designs. Not that all things can always be changed, but it's from our perspective problems with the mouldings.
It's interesting you're talking about 3D print files turning out, because I have a 3D printer myself. I print products from time to time. I hadn't considered the transition from a 3D printed prototype to an injection molded production process. There is going to be quite a significant difference, isn't there, between those two files?
We have rules that we have to follow, which 3D printers don't necessarily have to use. Things like undercuts and clips, we can make them, but it adds cost. So do you want them? We can advise different assembly methods so that you can disassemble if need be. It's the rules we have to follow to do the injection moulding side of things.
Yeah, so it's interesting. I get the idea that an OEM would want to be able to prototype quickly in a 3D print mode, but then you're acting as a bridge effectively to be able to then take that product to production.
It's the next stage. 3D printing is fantastic for very low volume, for the prototype stage, for 10s and 20s. But when you need hundreds, then you seriously need to look at the injection moulding. There is a big initial outlay for the mould tooling, but then you're getting your parts for, a pound instead of 30 or 40 pounds, whatever you're going to pay for the printing. And the payback time on a mould tool that does cost thousands of pounds is generally it can be a few hundred units, and you're there. So it's worth talking. Sometimes the tooling, the 3D printing does things the tooling can't, or it's going to be very, very expensive tooling. And we just give feedback to the customer on that as part of the quoting process.
Okay, so we've talked there about material minimization, so reducing material cost, reducing cycle time, so reducing energy and time involved, so reducing weight of the product potentially at the same time.
And also we can design out costing the mold tool through working with the tool maker. Is this feature, can you change this radius? It makes it, we can use a bigger cutter to machine out cavities, quicker machining, cheaper tooling. So like, some people will be very, they can't change the design at all because it's been approved, so we can't do it. But we can advise on how to reduce the cost of tooling, that initial outlay, which could be a hurdle to going down the mass production route.
Sure. And talk to us a little bit about the use of recycled material. I can appreciate some applications need the technical specification of a virgin material, but I guess there are opportunities for recycled material. Just talk me through how that process works.
Well, we are injection molders and we use thermoplastic. By definition, it's recyclable. Anything that we put out is recyclable and can be reused. We can, as most molders can do, is we can recycle our own product, and we do on site, and we can go up to 30, 40, 50%, and still achieve. Obviously, we don't just put it in; it has to be tested and approved because sometimes there's a compromise on mechanical properties of the plastic. But generally, with the thermoplastic, you can use some regrind in with the virgin. It just needs to be tested and approved, really.
So if an OEM was interested in moving towards a semi-recycled product, there's an opportunity, but you recommend a test process during that.
Automotive, a lot of automotive products that we're making specify virgin. Well, obviously we can't use regrind on that, so we have to use what they're asking for. Other people want to be seen to be using recycled material, in which case we can use it. We can purchase in recycled material if we don't do it. And there's a market out there, approved supply chains and feedstocks. You know where it's come from. You know what you're getting. If you're starting to look at recycled products, curbside recycling, some of that can get a little bit up and downy with its properties. So it depends on, again, we would talk to the customer about their requirements for it.
And what type of material groups would you typically use recycled for? Are there any restrictions on material groups?
No, not really. But some of them, like glass field materials, don't like it, so you can't go as high a percentage. The polypropylenes, ABSs, you can use styrenes, you can use 100%. But again, it's not necessarily the material specific, it's more product specific. So the process that we're actually going to be putting it into, and you don't know which of the mechanical properties has been affected, so you need to get them tested and be very thorough with it.
Talking about applications, would you like to just talk us through some of your examples here? And
a lot of what we do is enclosures for electronics, and some of these, as you can say, it's a box for a PCB board, but there's a lot of styling gone into a lot of them. We do two-shot molding, okay, and this one here is two-shot. And we also do encapsulation molding. Okay. Inside here, there's a circuit board. That is that, and in here there is actually an overmolded RFI chip. Right. So, and again, that was working with the customer to try and develop a process for it. That is
and elastomers and
a lot of elastomers. Okay. A lot of things we do for overshot, overmolding, two-shot molding is to grip. This one actually has a button in the side, incorporated in the side. So again, you can actually reduce the parts by bringing in more features, whereas you might have had to have a separate button on a part. You can design it in, so you're removing the need for a third or fourth part. Yeah. If you can, when you're assembling a part, put the clips into the chassis and get everything clipping to it rather than screwing to it. That's actually very early, just talking to a customer and saying, what do you need and what can we do for you? How can we help?
It's interesting. At the Sustainable Engineering Alliance, we have pillars of sustainable design. each of which a kind of an engineer can use as a checklist to see how they're working through their design process. And one is integration, the ability to integrate multiple functions into a molded product to reduce the necessity of multiple parts.
Yes, it can make the tooling more complicated, therefore more expensive. A lot of things, when you've got mechanisms on tools, sometimes they'll slow down their cycle because there's a lot happening. Right. Can add a cost to it, but the overall end net result is the fact that you're saving money, and obviously it makes it a lot more sustainable.
Well, thank you very much. You've talked us through a whole bunch of stuff, lots of useful and interesting advice.
Another thing I'd like to point out actually is that all tooling and moulding is done in the UK on the south coast, so carbon footprint is there's no shipping it in, and if and when maintenance is required for the product, we can actually do it on site very quick. We can be very reactive.
Fantastic. So material savings, weight savings, optimization, integration, carbon footprint, recycled materials. It's looking good. Okay, here we are at Hardware Pioneers Max 2026, and I am with Pete Wood on the RS stand. And we've got a big display here, some really cool technology, and Pete is going to walk us along the display. He's going to show us what's new, what's interesting, and what's useful, most importantly of all. So, Pete, over to you.
Thank you very much. Shall I carry that? Thank you very much. Good to see you, John. Thank you very much. So look, thanks. Welcome to the RS stand. Basically today we're showing a showcase of technologies. RS itself has a wide portfolio of products. However, what we're focused on today really is the AI on the edge stuff, so what we're calling sort of physical AI. We'll start actually with Design Spark, where my camp is, right? So with Design Spark, we are a large global engineering community for engineers, design engineers looking for design tools, looking for design solutions. We have lots of products and technologies from our welding suppliers. We have application examples, code, you name it. If you're looking to research a project, please come and check out designspark.com. Design tools start for free, and also you can upgrade to the premium versions as well. So that's Design Spark. And then moving on, the showcase that we have here of the kind of the AI products, AI on the edge. AI is now becoming even more increasingly easy now to get into. It's becoming very simple with the single board computer side of things. There's a whole ecosystem out there that makes it much simpler to adopt these technologies. And we start very basically here with the good old BBC Microbit now that have got some very sort of basic level AI kind of projects. And as we move through some other key suppliers at FIIOM, there's the PSOC here, very well known microcontroller platform. They'll start to move now into some of the AI stuff as well. And then we move into some more new kids on the block like the GRINN board here. So GRINN, again, targeted edge AI applications. We've got a bit of a demo running here that shows just literally a very basic, this is a person, this is not a person. I haven't tested it with anything else, right? So, which is good there, we can see ourselves. And then as we move through, we get to more power, basically, right? So this here is the brand new Arduino Venchiro Q. So it's the big brother of the Arduino Q itself. What's great about this is, first of all, it's not available yet. This is a demo, it's not quite released yet, but this is a super powerful AI platform. It can run LLMs, etc. This runs, I think it's about 40 tops, right? So it's just pretty impressive what you get for your money. And we've just got some very basic diagnostic data here because that's about all we can do with it in a minute. So we've got a chance to get our hands on it and build something, right? Then we move on to the good old NVIDIA series of products. This is the NVIDIA Orin AGX. Again, this is the supercharged AI side of things for the NVIDIA offer. We also have the good old Jetson Nano, favorite of mine, this $200 board. You can do so much stuff with this board. It's incredible, and we're running all kind of things on that. And then as we move through to the Arduino again, so the Q, which is the earlier version of the Ventrino here. This here is our PCB inspection unit we built. The whole concept is around how you can train a model very simply. What we've done with this, using in this machine vision sort of setup, is we've taken a set of boards. We've got some good boards and bad boards, and what this is basically doing is it's looking for a good board or a bad board, and what it does, when you put it, you'll see in a minute, we're detecting how many SOT packages are there. So if I put this into the placement here, and you look down at the little screen, which camera may not pick up, it's picked up 8 components. So when we press our little button here, we should get a green light. We do, so it's working. Imagine this on a production line. Obviously, they're all squizzing by and they're checking one at a time. And then if we put a bad board on, which is like this one, for example, it'll do the detection, it'll look at it. And of course, like any good demos, it's crashed during the demo, right? But what will happen is that will actually, oh, okay, so it's gone red. So that basically shows that it's not a good board. So again, a wonderful product, the Arduino Q, really powerful, fantastic if you're, used to the Arduino ecosystem, want to start getting into AI. They have a wonderful platform where you can get loads of project examples and stuff there, all for free. And as we move on to the last piece, this is the last demo that we built powered by the Arduino Q. It's basically an over-engineered video player, which basically talks about some of the proposition things that we have. So it's got these wonderful switches that would not look out of place in a factory, obviously, and we can just run some videos. We have our old school handset here, and you can listen to me, in fact, right? So again, showcase of AI technologies, talking about Design Spark here. I know earlier you spoke to our colleagues here at RS Pro. So and of course we have lots of other products in the catalogue. So please check out rs.com and designspark.com as well.
Excellent. Thank you very much, Pete, for fantastic demo of all of that lot. I've got a couple of questions on the AI inspection tool. So I've worked in these environments before, and training an inspection system can truly be a pain in the pants.
Yes.
Right. And in fact, we were interviewing someone yesterday. What was the phrase, Max? Automation 2.0. Yeah, Automation 2.0.
Okay.
Not come across that before.
Yep.
And that was, I think, the whole idea of kind of AI at the edge in automation environments. Yep. And we had this concept of a factory where every machine is just learning. Not just doing, but doing and learning.
Yeah.
Is this an example of that type of thing?
This is more about, I guess, how you can create a very simple machine vision type application on the line. Now, I guess at some point, if you use the more powerful product, you could start training it to recognize other anomalies, right?
Yep.
Right now, this is a very basic option, but it just shows the capability that these boards have got and how they're evolving. When you move over to the Venturo part, it's a lot more capability, that's a lot more powerful. And then, yes, you could start deploying applications, and then it could start teaching itself, I guess, and machine learning in that respect. So putting that technology in the hands of small teams that could experiment with this, and then start to capture information, process it, and then in theory build test equipment into self-learning machinery. Absolutely. That's what's wonderful about these boards. They're so accessible, they're inexpensive to some extent, depending which one you go for. But there's such a wonderful ecosystem around this that you don't have to start from scratch. There'll be code out there, someone has already done. We're big advocates of open source on Design Spark to get people basically ahead of and started. And then the great thing about the Design Spark community is you're able to if you're in that world, share what you've done with the wider community, and then learn from each other, and then you can go faster. Basically, that's the whole idea.
Yeah, I'm doing quite a lot of AI code development myself now, and the speed and capability is just shocking. And so to attach some hardware, and theoretically have an AI test rig up and running in a day, possibly, is madness.
And these are simple off-the-shelf components here as well. As you see, all of this stuff came out of the RS catalogue, just to plug it away. But so again, yes, you can lash up a system very quickly, proof of concept, and again, if there are models already out there, you can just drop them straight on, and you've got your proof of concept on the bench, and then you can move forward and evolve that from there. So absolutely.
Thank you very much, Pete. Great introduction. Good to see you.
Thank you very much.
All right, here we are at Hardware Pioneers Max 2026, and I'm on the RS stand, and I am with Stephen Sweby of RS Pro, which is a brand we know and love. And we're just having a look at a little bit of a display here. Now, obviously, in my past workplace, I have been manufacturing and assembling electronic circuit boards, and recently volunteering at a repair cafe. And a lot of the things we have to do with a repair cafe is disassemble products, take the printed circuit boards out, and go through rework processes. So some of the kit here would be aligned with just that. So, Stephen, can you just talk us through the kit we can see here, what it does, what makes it different, what makes it special?
I think from the products we've got here, we've got desoldering stations, we've got a soldering station, we've got ESD protection equipment, we've got a single board processor or computer, and some, again, a DI and ionizer, which helps you with your ESD when you're handling electronic products.
Yep.
This is just a real small part of our portfolio, which is really supported for hardware pioneers today. And part of my role is to make sure these products meet the quality standards of RS Pro. So we test, we validate, we make sure they're compliant legally, and make sure that our customers get really good value from the products we produce.
So for our viewers, RS Pro described as basically RS's...
It's our own brand, it's our own brand.
It's interesting, the kit here. Hot air desoldering for ball grid arrays and stuff like that. Yeah. Fume extraction?
Yes, fume extraction.
Yeah, okay.
Light there as well, so you've got
okay.
extraction into one unit.
Nice combo unit there with lighting and fume extraction, which is easy to overlook.
Yes.
Easy to overlook. And then deionizer, which is an interesting one. So, why wouldn't you have a deionizer? You just would, really, wouldn't you?
Would, yeah. And it sort of goes along with the sort of whole sort of ESD protection and make sure you're not building up any charges around what you're doing, and maybe on your gloves or your hands or whatever. And so it means you're just not damaging your boards when you're reworking or handling electronics.
Yeah, sure. And we have a product. So just talk us through this.
So this product is a single board computer, a little bit like a Raspberry Pi. It's a little bit more advanced, so we've got an NVIDIA processor, so AI capability there, and it enables you it's like a developer kit. So you can start building your own computer, your own electronics for whatever device it is. You can see it's really small, so you can, and the idea is people can take that and use it and develop as a sort of foundation in developing whatever use they have for a computer like that.
Yeah, brilliant. Excellent. Well, thank you very much for your introduction to all that kit, and I'm sure there are lots of electronics engineers out there who would love their workstation to look just like that. Right, here we are back at Hardware Pioneers Max 2026, and I am on the Altium stand, and I am talking to Tom Green, and I'm going to ask a very straightforward question, which is, what challenges would your customers be facing for Altium to be the solution? So give me a clue as to the industries they work in, the types of things they do, and the types of challenges that your technology solves.
Absolutely, John. So Altium as a whole, some of the challenges that would be faced from our customer base that we really excel in finding a solution for is integrations with third-party softwares, bridging the gaps between A and B to make sure there's a seamless integration, collaboration, connections, efficiencies, go-to-market time efficiencies, making sure that you have reliability in your parts and components, they're managed effectively, there's no manual processes, better behavior set. Condensing all that into being part of a digitalization project.
Okay.
We want to be making sure the customers are on the road to digitalization to prevent manual processing, to make sure that the correct behavior set is there, is scalable, it beds the foundation for continued success, which we measure in as a quicker go-to-market.
Okay.
Prevent respins, which is obviously the greatest thing within this industry, but also to make sure that it can be connected and collaborated with other parts of the business, such as procurement, when they look at life cycle parts manufacturing, bill of materials, and to make sure that the designers feel comfortable, confident and accountable for their designs when they push those forward into the mechanical and also the PLM as well.
Okay, so with that type of integration during that design process, I guess one of the challenges I face in a design process is if I can't pull that forward data back into the design process, it often catches me by surprise later in the process.
Absolutely.
They were talking about respins. Normally a respin because there's a gap in the data somewhere that you only discover later.
Respin because you may not have something, for example, if you don't have your managed workflows, providing the authorization at different stages of the design process to make sure that it's completely correct.
Yeah.
Design rules to make sure everything is following the rules that you set. Signal integrity to make sure that you have your power analyzer correct as well. Making sure that it fits into the mechanical molding as well. So once your PCB is pushed through, you're the mechanical co-designer, it needs to be able to fit into the molding of the mechanical. If it doesn't, you can then see that being pushed back. But with such things as version control that we have and making sure that you have the ability to all collaborate at the same time on a design, you'll be able to efficiently eradicate that, but create better behaviours to make sure that you can alleviate those problems in the future. And as you push those and integrate those into what we have as a PLM, the product lifecycle management, you make sure that those changes are made simultaneously. Any changes made in the PLM are made instantaneously in the ECAD environment, ECAD to PLM as well. So not connection, integration as well.
And in terms of product lifecycle management,
yes,
we're at Sustainable Engineering. We're interested in seeing industry go from a linear process where a product is designed, manufactured, used, and disposed of, to a much more durable, longer-lasting, cyclical type process. How would that technology contribute to that, do you think?
So with Altium, we are, imagine you start your PCB from day one. We make sure that we can actually look at the full go-to-market process. So you start your ECAD environment, you move into your mechanical, you make sure that it's all within the PLM, and then at any opportunity, you can pick up that design, that project, exactly where you need it to be at any point, and make sure you can make any alterations, rather than go back and look, it's all harmonious. So it's really establishing the difference between connection and integration.
Yes.
If anything in the mechanical tool, any alteration made will be reflecting the ECAD, the same in the PLM. So you can make sure you can eradicate all problems, and also if you need to then make a version 2.0 of a design or a project, you can go back in and really pick that up, so it's like a continuous process.
So it's a real-time environment, pulling in data from all those disparate points into a centralised...
Collaborating all three teams, PLM, ECAD, MCAD, making sure that they're all invested into the same behaviour set to create those efficiencies. We'll just encourage that so much better.
Okay. You mentioned product design rules.
Yes.
Can I set my own rules? How does that process work?
So within Altium specifically, so design rules will be if you need to dive into this a bit deeper, but if you need to obviously make sure that you can't do X amount, or the signal integrity needs to be X amount, you can set those design rules, which means if you then are to create on the PCB something which falls outside of that, you'll have an alert come up to say you're outside of this rule. If you then go back to what I mentioned earlier about managed workflows, at each point of the design process, once that's submitted to someone to review, they'll be able to review that as well. So imagine the design rules also, and the managed workflows together working harmoniously means that design is going to be a first time hit, being successful.
So this ties in, we're very interested in the digitisation of engineering. It sounds as though this is the kind of foundation of that process as it goes through, and we're interested in how that then spreads out into factory environments with sensors capturing data, pulling data back into the final product. I guess that can be reiterated back into the design process, so you can change your design rules and try and improve on things. I'll throw in a curveball question about artificial intelligence. I was bound to ask.
No, I think that's...
am I allowed to ask?
Yes. In terms of an answer, I may not be able to give a clear answer. All I would say that AI is something which Altium has on its radar. Absolutely. I think personally, from my experience of working out of the business for a long time, it's understanding how AI can benefit Altium. Because we have design rules, because it requires a human to be able to complete said projects, we need to be careful about this as well. But from what I know from internal conversations, AI is something that obviously the business are very heavily looking into. How that is then materialised, we're all looking forward to seeing.
Well, I look forward to seeing that too. I want, as a design engineer, I want that kind of angel on my shoulder overlooking what I'm doing from from an AI perspective in many respects, maybe helping me to refine those rules as I move along. I think it'll be nice in the future just to have that helping hand.
100%. I think keeping an eye out on the website for our agile teams, our agile enterprise solutions. Keep a weathered eye on the horizon for our solution, but ultimately we are really here to strengthen the foundations even further of what we've built so far, which has really been our USP, to really bring in different teams and to really harmonise the digitalisation process within the Econ environment, to really look at the full go-to-market process. Our integrations are getting stronger, our design, our tools becoming better, and we're really making sure that we can really bet the foundations of being the market leader in this industry.
But just to close, just to remind us about that kind of client industry sector groups again. You've got automotive, aerospace.
So within my team, we have a range of different industries. We have automotive, we have aerospace, we have defence, you have startup businesses in any sector, public sector as well. You also have industrial automation. You have service bureaus as well, incredibly powerful industries. I believe I might touch on their medical devices, government-based projects, or government-based environments. So, and also manufacturing as well, OEM components.
So pretty much everything from start-up all the way through to aerospace giants.
And to watch that organically build up, I've been very lucky to see some organisations really move through the product range into the environment they are, which is enterprise now. And it's meeting value with a solution. Absolutely. We highlight as much value as we can to that customer to make sure that the solution is ideal and catered to them. So by taking that sort of ethos, it's really positioning us and the new solutions that we have to make sure that we move into that software service.
Here we are at Hardware Pioneers Max 2026, and I am with Abid, and I am on the Ardencraft technology stand. And I love a diagram like this. I love a workflow. It's the way my brain works. And so, Abid, would it be best to describe you as a design and manufacturing authority? Is that sums you guys up, doesn't it? What I'd love to do for our audience is for you to talk us through this process, where you drop in, why it matters, what challenges you solve along the way. So talk us through this process. It's lovely to see.
No, appreciate it. Thank you very much, Sean. So the whole idea is we come and bring you on board on our design development journey. It is a journey. You've got to have very strict gates that we have within this, because you can't design something and immediately make thousands of them, right? So it starts with industrial design. Now, we're an engineering company. We work with industrial design partners. So within this, it's the look, it's the feel of what the product's going to be, what the key features are, and really how people are going to interact with it. And then you've got to make a prototype, right? You've got to say, all right, is it the right shape? Is it the right size? And you get a lot of feedback within this. And the idea is your requirements are quite open. Is you're exploring some. We use a must, should, could, won't. Right? The product must have these, and you naturally say it. It could have other features, right? A power bank could be wireless. It could have an LED screen, but must charge your phone, right? So you can suddenly see what the key features are from there, right? Because a lot of these features will also dictate on your price and how it's going to sit in the market as well. You can have all the features on your list, but then it'll be a very expensive product, right? And at the same time, you can have the core features, and you can start there. And actually, suddenly it's a relatively low cost but very value for money type of product, right? So there's a lot of ways your product can stay in the market, and that's what you're deciding at the beginning. After that, engineering validation. Here, you're really trying to finalize on your requirements. You'll add a few fun extra ones and be like, hey, is this possible? Engineering validation is your, let's get the technology over in China. Let's try to prototype it again with some more serious components and more serious designs. We spend a lot more time within this. And at every stage, we build prototypes. The idea is you have to be able to have it in your hand, just testing with users to really validate it, right? For example, I'll keep going to a power bank. Is it too big? Does it fit in your pocket? Does it actually look good? Is it charging the phone the way you expect it to be, right, within this? And same with the wireless charging. After engineering validation, the goal is no more changes on requirements. Right, is you've solidified it, you know exactly what's going to happen. You can't suddenly go for tooling and be like, hey, I want wireless charging. You have to change the tool, right? So we do this in a very methodical way so that you prevent a lot of reworks and changes, right? Because remaking tools costs the same amount as making new tools.
It's an important one.
Yes. And so design validation is our next attempt at making, we call them golden samples, but what you're doing is you now look at all the components, you've got the requirements, and you say, right, how do we make this more efficient? Are we using the right type of components? Are there better ones like on the battery management that we could be using, or increase the level of safety, or how quickly it can charge, right? And explore on the pricing as well on the components is like, is this the right type of mixture within it? Because ideally what you want to do at design validation is, and again, we call this EVT, DVT, PVT. It's quite a standard, a lot of engineering companies use it. People hear it more in that way. Design validation is your chance to review everything. Maybe there's a requirement change, hopefully not, otherwise we'll repeat. That's our line before tooling. As soon as we hit tooling, that's it. I mean, you can change, but it's going to be very expensive, right? Your tooling is your first set of expensive pieces that can range anywhere between 10,000 to 100,000, right? Pounds. So our idea is now at design validation, we've got a good, almost golden sample, but we pretty much know what we're making. It's not going to deviate too much between it. We make our tools, we go through our tooling samples, there's a lot of injection within this, and we're basically right after tooling going to golden samples. So these are golden samples without tools. Now obviously tools are going to vary on mechanical. The electronics doesn't change too much, but definitely the mechanical elements of it, the look, the feel, the color, the texture, and any mechanisms you've got mechanically. We've golden samples. So in theory now, after tooling, that is what we're going to produce. We share that with our customers, we share that with our factories, we get signed off like, right, this is what we're making. That's why they're golden samples. Might take us 1 or 2 tries, but the whole point is everything's captured. Right, we've captured all the requirements, we've done the user testing. We're now doing more reliability testing, right? And I guess DVT we didn't talk about, we have to do reliability testing. Is actually the button we choose, will it last 5,000 clicks like advertised, right? We will literally do 5,000 clicks, right? And same with drop tests, vibration, temperature, humidity, there's loads you can do, right? So yeah, golden sample with the tools, production validation. PVT, more with the factory. So now you're looking at the factory, you've chosen your supply chain, and we do that within DVT. You choose your supply chain, your sub-suppliers, and then you've got to optimize for them. You've got to look at their manufacturing processes, what their standard operating procedures are, what their QC procedures are as well. And it's a good way of also, when you're making a product, yes, the BOM is a cost, but this is like just-in-time manufacturing principles. We talk about this in car manufacturing is the less time you spend on a product, the less costly it is. Right, is if you can spend 7 minutes on a product rather than 10 minutes, those extra 3 minutes you're paying for. That's factory time. And so, yes, we've got to make sure everything's tested properly, right? Is now we're at the factory, physically there, how do we reliably test it over tens and thousands of units, right? So you can see how the focus just going is on the user, is on the product, moves to the manufacturer. And again, we're making samples. We're making sure, right, we set everything up, do the testing, do a round of samples, and then again, pilot run. That's our first chance. We'll make hundreds of units. Yes, certificates. Yeah, good catch. So obviously, as we're going through production, validation, we certify the product. Stolen samples, let's go certify it. C for Europe, FCC for US. PTSRB is a IoT connectivity standard for the US. So when you're mass deploying products in the US, they don't want, let's say, 10,000 units suddenly join the network, but it's really buggy on the network, they'll just kill it. They'll be like, hey, what is this device? Because they could cause downtime for all the other users. So PTSRB is their way of making sure that you're connecting in the right way, you're not going to disturb their network, you're not going to disturb everyone else's cellular network, right? And so that's the American standard. There is equivalent in Europe as well, but that's when you're mass deploying. Pilot run. You need hundreds of units. Again, give it to your key users, get people to play around with it. You're going to have trials, you're going to have people asking for samples. So we build that in. I don't like telling factories the pilot run is mass production because they get upset. So instead we build it in. Hey, this is another set of samples, but now we're testing the test jigs. We're testing all the processes again.
How many would you typically make for a pilot run?
It will vary anywhere between 100 up to 1,000.
Okay.
Sweet spot is usually 500 units, is thereabouts. But you can already see that someone's who's trying to get orders, but they don't want to say, hey, it's a 500 unit order, we inbuild that in. Because then afterwards, we can typically do slightly bigger pilot runs, 1,000, 2,000, 3,000. Ideally, as you're going to mass production, the factory does want 5,000, 10,000 units. But it's a chicken and egg, right? You can't build 10,000 units without the orders for 10,000 units. And equally, you need units for the orders. So that's why the pilot run's important. We build that in within this so that actually you can get on the ordering process. And after that, of course, QC inspectors. We do initial factory assessments during production inspections. We've got 10 full-time QC inspectors in China, boots on the ground, really making sure what we've built and what we've designed at the factory, what we've designed at the product is actually happening. Right, it's a very different story. Things can change. If you imagine building a product, it's thousands of people across dozens of factories, all singing the same hymn sheet, right? Things go wrong. And you've got to be able to pick up on that, hopefully quite early, and then you're able to effectively ensure it's good quality. Right. And finally, the last one, we've got intellectual property. Again, we work with several partners around that. There comes a time, again, IP, it's up to the customer, up to the brand, how you want to do it. You could do it at the beginning, you could do it at the end. It's a long process anyway, and you can backdate it. So in theory, when you're ready to ship, you can already kickstart that process within this.
It was there rather than there, but it can be backdated.
Yes. Can be backdated. Because at the end, because ultimately you're not really putting it in front of people until that point, right? And you don't want to pay for IP right at the beginning because you've got to pay for the product. And so we do see as a trap sometimes is you spend all your money on IP and you don't have any money for your product because IP is not cheap. So you'd rather do it at the same time because you're gaining traction, right? You've hopefully sold about 1,000 units. You've got all those people interested. You've actually got that rhythm, and now you're hopefully getting more money to then actually work on the IP and get ready for mass production because it gets more and more costly, right?
Give me a clue for the types of products you work on. What does mass production actually mean? What sort of numbers?
Great question. It'll depend on the factory we select. So quite early on, we'll anticipate numbers, right? Some of our smaller, again, good quality factories, how we assess it is how many products can the factory make in a day? Because if they can make 1,000 units in a day, it will still take them one day to make 500 units. But you're still paying for the setup, the first article inspection, and all of that worker time. Because once you leave it going, it just prints. Right? So we do it in how many days? Ideally, 1 day of manufacturing minimum. Ideally, a week is a good amount of time, right, of the factory continuously going. So if it's a much bigger factory, like for example, we've got access to some massage guns that they can do 2 million pieces in a year, suddenly their day rate is massive, right? Suddenly you talk about 20,000 units, but smaller factories, and you've got to have a wide range of factories within this. If you gave them 2 million pieces, they won't be able to cope, right? So it's all about finding the right type of factory, and that's why we're almost factory agnostic. You've got to have the right type of factory, the right size, in the right place to be able to build it up.
I seem to recall you mentioning you've also written a book about this. Would you like to just show our readers your book? Which I think is now available.
It is. It's available on.
That's right. Yeah, hold on.
It's available on Amazon. Yep. It's called Entering Chinese Manufacturing with Confidence. Right. And it's my way of showing people how I go about Chinese factories. So the book starts with a checklist, and it's a checklist for you to ask yourself. Right. It's how's the communication with the factory? Do you understand all the technical pieces for your own factory and your own products? What questions I would ask when I visit a factory within this as well, and what clues, red flags, green flags, because you could go to 10 different factories. Some will be really good, some won't be. It's how do you differentiate the same type of factory? And the idea is after this checklist, the book explains the checklist. So I explain why it's important, my red flags, my green flags as well, and how I go about different factory patterns as well.
That's right. Well, I love a checklist. My whole life is based on checklists, so I'm pleased you've done it that way. How do our viewers get hold of a copy of this?
So you can go on Amazon, type in entry Chinese manufacturing competence or Ardencraft, or go on our website and I could get a link. If you speak to me very nicely, we have some copies on display that we do give out. But yeah, no, I wrote this book over a year ago. We kept hold onto it because this book entirely written by me, zero AI, and I know the moment you publish it, AI has it. So for a full year, we didn't put it online, didn't put it on Amazon. You get to speak to me and get a bespoke copy, and now it's on Amazon. Maybe there'll be more fakes out there, but at least I've written it with a lot of care that I didn't even want to put it online because I was worried anyone would take it.
And if they contact you directly, maybe even a signed copy.
Yes. yeah, happy to give a signed copy of that.
Well, thank you very much for your time. This has been fascinating. I mean, there are different products suit different manufacturing environments in different regions. A lot of products suit production in China. Getting there for maybe startup companies can be a real hill to climb if they don't know what they're doing, if it's new to them. It's nice to know that there are organisations like yours that can help them along that process. I think the walkthrough of that was really important. I can imagine lots of our viewers taking a screenshot of that as a guide. So thank you very much for your time.
Appreciate it.
And we will point people in your direction. And if your book is a start point, then fantastic. So thank you very much for your time. Right, so here we are back at Hardware Pioneers Max 2026, and I am on the Gelec stand, and I am with Dave English, Managing Director. And what I thought we would do is take a look at this display case, because this is fascinating, because any product is a combination of all the components on its bill of materials. And to be at a single source, if necessary, a whole raft of different technologies, that's highly productive, it's good for purchasing, good for integrated design. So I'm going to get Dave to walk us through this case, because we've got metal components, rubber components, thermal management, moulding and cases. So Dave, tell us how all of this works together for your customers. How do you solve their challenges?
Okay, so we're here for Hardware Pioneers, showing the enclosure side of our business that we do. We have a complementary set of products. They don't always at first glance come across as complementary, but over the years, we've had 50 years in business, we've been given a lot of different opportunities, and it means that our customers can get their products from one supplier supplying a whole bunch of stuff for them. So starting at the bottom, we've got metal products with forging to give strength. This product is for an airport runway light, which gives incredible strength. High pressure die casting, and then stamping parts with painted and coated finishing. Also have those EMC if required. So that's the kind of the metal side of the business that we do, and interesting little handles with a silicon coating on it to make it nice and to touch for our customers in their application, 19-inch racks. Yep. Moving up, we've got a very small selection of the type of keypads that we do, which are used for input-output, rubber as well as keypads. Here we have a twin-shot rubber and plastic part together, which gives it flexibility. And then we also have a further plastic and rubber, in this case a lens, which gives strength as well as flexibility to our customers' designed.
Yep.
The keypads that we do vary dramatically, but sometimes they can form the front part of the instrument, and give it complete IP rating. Otherwise, they can be fitted underneath a plastic moulding, so you can access the keys, but it's covered by a frame. And then we also have membrane keypads, which come with labels on the back, and they come gold-plated if required. Okay. Moving up to the next section, we're into our thermal management. We work with Sunon, which is the world's best, in my opinion, fan manufacturer, managing a whole range of EC, AC, DC fans, moving into the HVAC world as well. So it's been an incredible partner for us for over 40 years. And very, very good in server applications, anywhere where there's a hot spot in a design with an enclosure. We also supply them mounted in a cassette for a customer's application if required, so for ease of assembly for high volume production. Yep. Moving up here, we've got a very limited supply of the type of plastic injection moulding parts that we have. This is a small enclosure, which, as you can see, the gasket sits inside the fixing screws, which gives it an IP67 rating. This is a twin shot, so thermoplastic overmolded onto rubber. So it's a robust product that feels good in plastic and also is soft and doesn't get damaged to protect what's inside. And then we have some other general plastic mouldings. With these parts, we often supply things like battery contacts, nutserts to help our customers to make the assembly of their products easier. And then we've got a simple assembly here. This is actually for the health market, where we've got a reset button and that as a strap goes in there, can fit around a knee. Okay. And then just moving up to the top, probably in the last 5 years, a number of our customers asked us, could we supply cases to protect their instruments, one of our instrumentation customers. So we produce these EVA cases, which are very, very strong. Yep. And they can come in a variety of different finishes to make it aesthetically pleasing if the customer wishes, and you can customize the inside to maintain and hold the product. So yeah, that's the products that we're showing here at Hardware Pioneers.
Yeah, fascinating. So a real selection of technology types, which, as you say, at first observation don't necessarily look as though they go together, but in reality, of course, they do.
Yeah, my customers often say so.
Yeah, fascinating. So, yeah, probably half a bill of materials covered there potentially. You just need a printed circuit board and some components.
We're also open to sourcing any additional parts. If someone has a hard-to-find product, we have an office in Shenzhen, China, and a couple of warehouses over there. Okay. We're also sourcing now from other parts of Asia, the Philippines, Vietnam, and India as well. So we have those options.
Yeah. So just because you can't see it here doesn't mean to say you can't get it.
Exactly right.
Yeah. Okay, John. And one of the things at Sustainable Engineering, we've got this model of we call ACT, which is awareness, confidence, and trust. So we're making our readers and viewers aware of the problems you've solved. In terms of confidence and trust, it's all about sort of the team and the brand. And you mentioned 50 years, did you say?
Yeah, 50 years.
So you've been solving problems for 50 years. So our viewers can be confident that you can get it right.
Yes, we plan to be here in the future. Yes. Don't worry, and we've got a long past.
And in terms of trust, that's all about people. You've got engineers on staff that are working with your customers to get the design of these components right first time?
We do. We have a number of product managers within the organisation. We have our own UK quality people. We also have our office in China, and we work very closely with the engineers of our suppliers.
Yeah, brilliant. Excellent. Well, fascinating introduction to the range of services you guys do. So thank you very much for your time, and see you at another show soon.